managing data less error prone. SQL stands for Structured Query Language. It's a language for interacting with relational databases. Relational databases are structured like a traditional table with columns and rows. If you're not familiar with SQL, I highly suggest taking a peek at the prerequisites for this course. I've also listed them in the teacher's notes below. This prior knowledge will bridge the gap between working with a database using SQL and working with the database using Python's SQL Alchemy. If you would like to follow along in Workspaces, then go ahead and open up the workspace attached to this video. In the console, run pip install SQL Alchemy. Hit enter, let it download, and you're all set. If you would like to follow along locally, create a folder for your project and open it in your IDE of choice. I'm going to use Visual Studio. I'm going to go ahead and create our models.py file. We'll need to download SQL Alchemy highly suggestible Studio. Load SQL Alchemy on a / SQL important for us to get out. They will need this file. If you do want to post this on GitHub, then let's also create a git ignore file. New file does not local environment change quite frequently. So if you're on a newer version than I am, make sure to check the teacher's notes throughout the course. This way you get the most up-to-date info.
Wow, I just got approved for this new test.
My name is Megan, and I'm a teacher here at Skills with a small project. I have here a file full of great books from SQL Alchemy, import and date, because we'll need that for the publish. This is getting a little parentheses, so then I can split them onto multiple lines.
These spaceships, there's a whole lot of SQL going by, and that's because the Space Invaders game actually stores all of its state in a SQLite memory. Overview of SQL Alchemy. When we do this talk more formally, there are some things that are good to know that would make the talk more understandable. Basic knowledge of SQL and order of importance. If you know about create table, how tables work, columns, querying, rows with select, modifying data with insert, update, delete is good to know. The general idea of a transaction is good to know. And joins, SQL joins, grouping, not that important for what we're talking about. Just things that I'm going to be showing how to do in SQL Alchemy, and if you don't know what they are in SQL, it would make less sense, but you can always review later. Overview, if you know what they are in SQL, it would make less sense, but you can always review later. And if you don't know what they are in SQL, it would make less sense, but you can always review later. Overview of SQL Alchemy. I need to make sure I'm looking at the time. So for this, we have till 20. We call ourselves the Database Toolkit for Python, introduced 2005. It's an end-to-end system for working with Python database API, relational databases, SQL language. You'll notice that I change how I pronounce SQL between SQL and SQL. I tend to say SQL, but I think SQL is probably more correct, so you're going to see me just switching. We're currently on 1.3.17, and 1.4 is the version I'm working on quite a lot, and that's considered to be what's I'm calling a transitional version to SQL Alchemy 2.0, which is basically goals of SQL Alchemy: provide helpers, tools, components to assist with an automate database application development, provide a consistent, fully featured facade over the Python database API, industrial strength but optional object relational mapper. SQL Alchemy is not just an ORM. We've always made sure that we're not just the ORM. If you don't like ORMs, you don't have to use it. Act as the foundation for a number of third-party or in-house tools. Boop, boop, boop. Philosophies: bring the use of different databases to interface as consistent as possible, but expose the distinct behaviors and features of each backend, and they all have that. Especially Postgres probably has the most crazy features, and we try to expose them, and we try to let you use a database to the full extent that that database allows, while still having the majority of your code be agnostic between different databases. We don't hide a database. We're not about the idea of an abstraction layer hiding a database. You need to know about SQL to work with SQL Alchemy. What we're trying to do is provide an automation layer, and DRI means don't repeat yourself. And then we're trying to favor declarative and compositional patterns over flags and switches whenever possible. And I think that'll just be, you'll see that when we do some code examples. Hopefully there's not too much prevalence of one big function with lots of flags. You're going to see more compositional, X becomes Y becomes Z, so it looks a little more natural. And we really want to stay true to SQL. And this is something that other tools don't necessarily stress as much as we do. We don't want to invent a new query language or relational paradigm. We really want, when you work with SQL Alchemy, to feel like you're working with SQL just in this way that's more automated and less boilerplatey. This diagram is on the website, so people who've read the docs have seen this is what you call a pancake diagram, because you have these different layers sitting on top of each other. The highest layer is the object relational mapper that builds on top of SQL Alchemy core. Core's major components are schema, SQL expression language, engine, connection pool, and dialect, and then all of that talks to the Python database API, which is your driver, like PyPG2 or MySQL client, PyMySQL, CX Oracle. Then bullets for those things. Engine is a factory for database connections, which are maintained by a pool. The dialect sits underneath the engine. It's hidden, usually, and it's the thing that knows about you're using MySQL or you're using SQLite. We know about how to generate SQL for that. The connection pool, is kind of basically where connectivity is maintained. It's not necessarily a pool. It usually is a pool that stores connections in memory, but the examples today will be using a pool called a null pool, which actually doesn't pool, it just connects and disconnects each time you use a connection. SQL expression language, we use Python to create SQL queries. The schema system is using Python objects to represent DDL concepts, tables, columns, data types. And then on the ORM side, the schema system is using Python objects to represent DDL concepts, tables, columns, data types. And then on the ORM side, which hopefully we'll get to near the end of the talk, probably about, 11 o'clock is when we hope to do ORM. Maybe a little late there. Construction of Python objects, which can be mapped to relational database tables. So basically, this is where you're creating business objects like your official banking application or whatever you're doing. And then your objects have data that's in the database. They can be persisted. Someone's got a microphone on with breathing. Transparently persists objects into their corresponding database tables using the unit of work pattern. Provide the query system, which loads an index, which probably DDL. So basically, this is, someone's got a microphone. Provide the query system, which loads objects and attributes using SQL. That comes from mappings. The ORM builds on top of the core, and it presents a slightly more object-centric perspective as opposed to a schema-centric perspective. Sometimes I have to move. You might not see, I have a little Zoom group chat, and I have to move it to see the end of my slide, but we'll work with that. And then I got to change the focus. Move it to see the end of my slide, but we'll work with that. And we're not going to do much with in the talk here, but they're there just to know about. There's an event system, event hooks throughout SQL Alchemy to tell when things are happening. You can modify how things work. The inspection system provides insight into various objects like engines, mapped objects. The SQL Alchemy extension package is a lot of extensions, mostly ORM related. If you're writing a third-party dialect for another database, a lesser used database or some other database that's not included, there's about 20, 30 third-party dialects on the site now. You would want to use the SQL Alchemy testing package. It has a compliance suite, so your test suite would be using this suite. And there's a SQL Alchemy.examples folder package that has an in-depth performance suite, and it's also where you get your free Space Invaders game. So rush right out, get your free Space Invaders game. So the big thing I'm working on, and it was kind of inspired by Python 3, Python 2 being retired, and Python 3 having a lot of great stuff. 1.4 and 2.0, the standardization of Python 3, SQL Alchemy is on the path to an all-new 2.0 release. Major features: streamlining of APIs, and it's going to be a pretty deep cut into pretty much every legacy pattern that has ever bothered me. A lot of the patterns in SQL Alchemy still date back to the 0.1, 0.2 days when we had a completely different way of working. And you know, we changed the APIs pretty dramatically, but we still kept things around from the earlier ways of thinking, and it's time for those to just go. So when you upgrade to 1.4, your code that runs SQL Alchemy now in 1.3 will continue to work. For the most part, there's a couple of, if you have some internal extension stuff that might change a little bit. 1.4 works like 1.3, but it has all the 2.0 APIs present within it. Sometimes you'll have to import from SQLAlchemy.future. I'll show that how that looks. And then you can have the 2.0 version, and there's a deprecation mode so that you can migrate your application to be totally 2.0 style, and then you can migrate. Hopefully by then SQL Alchemy 2.0 will be in beta, and then you can try 2.0, and you'll have, I think, hopefully much more readable code, faster code, because it includes caching. Major changes for 2.0, it'll be Python 3 only. We're still doing Python 2 for 1.4 because we're nice like that. People still are struggling on Python 2. Engine is going to get very refined. The engine level auto commit will be removed, but there will be another way to do auto commit. Connectionless execution is removed. The result set is very refined. It's got many new features. Rows are completely tuple-like, and a lot of nice stuff with results. The vast majority of SQL compilation is going to be cached, meaning that when we generate the strings, all the Python overhead of that is usually going to be cached for most of the regular bread and butter SQL statements. The ORM query is now, this is actually in master, this has been committed, is unified with select. You can actually use a select object instead of query to get ORM rows. And as far as if ORM query goes away entirely, that's still a little bit up for grabs. But technically ORM query won't be needed. You can use selects. And then also when you use selects and use all the new style, you get back the result sets for both core and ORM queries and all of the same ability to slice up rows and uniquify them or get certain columns only, get scalars. There's been a lot of requests for more flexibility in how ORM results are returned, so this will give it to you. This is the onion diagram. This shows the 4 components of SQL Alchemy, or SQL Alchemy as I usually call it in my head. These colors actually match to the colors in the first pancake diagram. These are the 4 main components, and we're going to start from the inside. Let me see how the time is going, see how long I'm talking. Okay, so I'm going, this is good. I'm speaking fairly relaxed, and I'm actually ahead of the game, so maybe we'll have time to get through all of the material. And also, I'm assuming people are going to, I'll see questions in the chat if people wanted to, have any curious transactions on Python database interface. And this is what a DB API is, a spec. The database APIs are super different from each other. And this is what a DB API looks like. This is the PsychoPG2 DB API, which is pretty popular. It's got some performance issues, but it's the one most people use right now for Postgres. There's some others that are more async IO oriented right now. There's actually a PsychoPG3 in the works that will also do async. But for now, a DB API looks a lot like a connect, where the arguments are kind of open-ended for different database APIs. You want to get a cursor to work with SQL. The cursor is also how you fetch rows. You want to get a cursor to work with SQL. The cursor is also how you fetch rows. The cursor represents an active, resource, so you want to close that at the end. And then the connection itself has a commit method. So Python database API does not have any auto commit turned on by default. So this is not SQL Alchemy. This is the Python database API that SQL Alchemy is going to internally use in order to do things. Important DB API facts. The DB API by default is not auto commit. There's always a transaction. You have to call commit or rollback when you want data. You have to call commit when you want your data to go in. Database APIs achieve this by employing an auto begin, meaning when you first run a statement or first connect, sometimes depending on how they want to do it, a transaction is begun and it's open. Most database APIs now have an auto commit feature that turns this thing off, and SQL Alchemy supports that. There are 6 different bound parameter formats for database APIs. Bound parameters are obviously, well, they're not obvious, but they're very important to use because that's how you take numeric dates, textual values, any kind of user input, and that is part of a SQL query. You want to put it into a bound parameter so that the driver can make sure that that string is sent to the driver correctly. It's also safe stringed. It removes the possibility of SQL injection attacks. It also has a lot to do with coercing the typing information, so basically, so that the driver can make sure that that string is sent to the driver correctly. It's also safe stringed. It removes the possibility of SQL injection attacks. It also has a lot to do with coercing the typing information, like a date needs to be formatted a certain way, or a binary needs to be sent in a certain encoding, things like that. But the Python database API decided to have 6 different formats for no reason I can imagine, and it's kind of inconvenient. And as I already said, they have lots of inconsistencies, and in my opinion, it's not possible to write non-trivial DB API agnostic code without using libraries. Meaning, when people say I'm just going to use a DB API, well, fine, you're going to be hard coding to a certain database for sure. Anything non-trivial, because they're all very, very different in how even simple things are done. Quick sample API consistencies. They all have different. I mean, there's a standard exception hierarchy, but you have to import those classes from that module, so it's not easy to catch an exception in an agnostic way for 2 different database APIs. If you want SQLite, there's no datetime. You have to turn them into strings. Other DB APIs will take the dates. If you're on PyODBC with SQL Server, you might find that sometimes your index don't get used because Python 3 Unicode strings are going to force it to use nvarchar for some data types. What is the artifact of Mike's screen? This is what you're going to be doing. And then this is a big deal that people don't notice, but it is very complicated. When you insert rows in a database, usually, not always, but often you have integer primary keys that auto-generate from a sequence or auto-increment or identity. The act of creating that new identity and then getting it back from the row is this completely crazy thing that is totally different on every driver. I mean, it's not totally, but there's different techniques that you need to use for different databases and different drivers. And SQL Alchemy is one of the very first goals was to normalize all that. And it's just a complicated thing. Single bound parameter format, fixed exception hierarchy, but we don't have the same messages. So if a certain database spits out a certain exception message, it's not going to be the same as a different database. There are ways to normalize that too, but that's not part of SQL Alchemy. And then when you see me come to this slide that has this slide REPL thing, that's where we go to the slide REPL thing. And if I can get to there, so now you guys should see a terminal window. So this is what it looks like when you create a SQL Alchemy engine. Anyone that's already used SQL Alchemy has done this because this is basically ground zero for how to get to your database. And there's a URL for SQLite here. If you were connecting to other kinds of databases, there'd be like a host name. It'd be like, MySQL Scott Tiger at host name, database name, like that. Those are another kinds of URLs. When you do create engine, it didn't actually connect to anything. It didn't create any socket connection. It didn't open the SQLite file yet. It just basically verified that your URL makes sense. It loaded up a driver. It loaded up a dialect, SQLite dialect. It has the pool inside the null pool, which hasn't done anything yet. So it hasn't connected yet. It's just kind of set up what you're going to be doing. And then, for the purpose of these slides, you're going to see this in a couple of things. There's this thing called future, and this is where I'm going to also try to show some differences between the 2.0 style of doing things and the 1.x, we'll call it, style of doing things. There's a package called SQL Alchemy Future that's in master. It's not in 1.3. It's only in master, which will be version 1.4. And it has basically a create engine function and has a select function. That's all it's got, 2 functions, and that makes all the difference. So we're going to make another engine that I'm only going to refer to a little bit, which is the future engine. Basically, it's from SQL Alchemy.future, import create engine, the same create engine with a little flag set on it, basically. And we'll call it future create engine. And we'll make a second engine that's called future. And the reason I'm doing this is so that later when I show you how to get result sets, I'll show you the slight little differences between the 2 engines. Does that make sense to people that there's 2? See, I wasn't sure if I should be introducing this in a beginner tutorial, but I also wanted to kind of show people who know this SQL Alchemy, here's the 2.0 stuff. So people
future is 2.0.
Yes, anything that's future is 2.0. However, this package will be in SQL Alchemy 1.4. And when you're in
the future package will be in 1.4.
Yes, the future package will be 1.4. And then when you go to 2.0, the future package will still be there. However, that'll be just a synonym for just import SQL Alchemy.
Understood.
Does that make sense? It's a little weird, right? the thing is, the future packages ended up being so small that I might not even do it like this. It's literally 2 little things. So maybe I'm not going to have it. For now, this is how it. If you get master from GitHub and you want to use the future stuff, this is how you get it right now. So yeah. So back to our normal engine without the future stuff. Now we're going to actually connect. So now we have this object called the SQL Alchemy connection, and what's happened is SQL connection dot connection dot connection. There's 2 of them. Connection is the SQL Alchemy connection that we'll work with. Connection dot connection is this little magic object that you don't need to know about called connection fairy, and people have that track to it. And don't, there have been the data and have statement equals text select emp ID emp name from employee. I should also note that this slide runner thing actually created some tables for us, and that's why this is going to work. The SQLite database has a table creator already. And then, so basically I have this statement called from SQL import text, create a statement object with some string in it, and then we're going to execute it. We're passing a parameter of 2 for emp ID, and then we'll get a result back. And then when I press return, you'll see SQL logging. That just shows what we just did. One thing to note is you notice the bound parameter in the executed SQL is a question mark. That's called QMark format. That's one of the 6 database API formats. So SQL Alchemy, in this example, converts from its internal colon format to question mark, and then you see that. So far, so good. When we have a result object back, it acts a little bit like the Python database API cursor. It has methods like fetch1. It has rows that come back as tuples. They're actually not quite tuples. They're first and foremost, they're named tuples, meaning the names of the columns are in the row as names you can access, and they're actually here with keys. So emp ID and emp name are the keys. And this is actually the first place where something is changing in SQL Alchemy 2.0, is that they're going to be even more like tuples. Right now, for SQL Alchemy since 2005, if you have a row, you can also use it as a dictionary, like this, a row with dictionary brackets, and then the key name. And the problem with that is that's what we call Python dictionary or mapping. It's not actually fully compatible with being a tuple in every way, shape possible. So you can always where you use a string name for a column name, you do dot underscore mapping first to get the dictionary view of the first version. The contains so you can look at dot name. You can look at it's a little redundant. The reflection called SQL object.
Welcome to Introduction to Databases in Python. My name is Jason Myers, and I'm a software engineer whose area of expertise is in developing data analytics platforms. Relational databases are the foundation of many applications and data systems widely used today. They are also extremely common in the world of data science and analytics. Relational databases are made up of tables which store our data. For example, here are a couple tables from the census database that we'll be using in this course. The census table on the left holds location and demographic information along with population counts from the US Census data. Meanwhile, the state fact table on the right holds additional details about the states themselves, such as the abbreviation and type of the location. Tables themselves consist of columns and rows. The columns of a database define the name of an element or field in our data, such as the age column highlighted here. They also specify the data type, such as a string or an integer, which we'll talk more about in a later section. All of the data in a table is stored within the rows of a table. The row highlighted here contains the population counts in 2000 and 2008 for newborn females in New York State. Tables can also be related to one another by a column acting as a key or a bridge that tells it which piece of data it is associated with in another table. This feature is where relational databases get the relational part of their name. Here we've highlighted the state column in the census table and the name column in the state fact table. We can use this relationship to get additional information about the relevant state, such as its abbreviation for any row in the census table. The structure of tables in relational databases, along with how they can be related as outlined here, is known as the relational model. We'll soon learn how to extract information from such a database, but first, let's test your knowledge of the relational. In the Python world, there are several great tools that we can use when working with databases. One of those is SQL Alchemy that we'll be using throughout this course. SQL Alchemy will allow us to generate SQL queries by writing Python code. you should still consider learning how to write queries in SQL as well. SQL Alchemy has two main components. The part we will be focusing on is often referred to as the core part of SQL Alchemy. It's really focused around the relational model of the database. Additionally, there is the object relational model, or ORM part of SQL Alchemy, that is really focused around data models and classes that you as a programmer create. There are many different types of database, and each database type has its own quirks and unique capabilities. You'll commonly find SQLite, PostgreSQL, MySQL, Microsoft SQL Server, and Oracle when working with data. SQL Alchemy provides a way to operate across all these database types in a consistent manner. To connect to a database, we need a way to talk to it, and an engine provides that common interface. To create an engine, we import the create engine function from SQL Alchemy. We then use the create engine function and supply it a connection string that provides the details needed to connect to a database. Finally, once we have an engine, we're ready to make a connection using the connect method on the engine. It's worth noting that SQL Alchemy won't actually make the connection until we give it some work to execute. So to review, an engine is the common interface to the database, which requires a connection string to provide the details used to find and connect to the database. Before we go any further, let's talk a bit more about connection strings. In their simplest form, they tell us what kind of database we are talking to and how we should access it. In this example, you can see that we're using the SQLite database driver and the database file named census_nyc.sqlite, which is in the current directory. Now that we have an engine and a connection, we need to know what tables are in the database. We'll start again by importing the create engine function and creating an engine to our database. Finally, we can use the table names method of an engine, which returns a list of tables. Once we know what table we want to work on, we need a way to access. Finally, we can use the SQLite, which is in the current directory we're talking to, and how we should access it until we give it some work to execute. So to review, an engine is the common interface to the database, which requires a connection string to provide the details used to find and connect to the database. Before we go any further, let's talk a bit more about connection strings. In their simplest form, they tell us what kind of database we are talking to and how we should access it. In this example, you can see that we're using the SQLite database driver and the database file named census_nyc.sqlite, which is in the current directory. Now that we have an engine and a connection, we need to know what tables are in the database. We'll start again by importing the create engine function and creating an engine to our database. Finally, we can use the table names method of an engine, which returns a list of tables. Once we know what table we want to work on, we need a way to access that table with Python. To do that, we're going to use a handy process called use the table name names method of an engine, which returns a list of tables. Once we know what table we want to work on, we need a way to access that table with Python. To do that, we're going to use a handy process called reflection, which reads the database and builds a table object that we can use in our code. We've already created our engine, so we begin by importing the metadata and table objects needed for reflection. The metadata object is a catalog that stores database information, such as tables, so that we don't have to keep looking them up. To reflect the table, we initialize a metadata object. Next, we use the SQL Alchemy table object and provide the table name we got earlier from the table names method. We also supply our metadata instance and then instruct it to autoload the table using the engine. Finally, we can use the function repr to view the details of our table that we stored as census. This allows us to see the names of the columns, such as the state and sex columns, along with their types, such as varchar and integer. This process of reflection may seem like a bit of overhead, but it will make understanding your databases and extracting information from them far easier downstream. Now, finally, we use the SQL I've already created. To do that, now that we have an engine, and there's simply, it's worth noting that SQL driver know what we're going to use a hand log that stores database object and provide the log that we're going to use directory. Once we know an engine, we need a way to access that table we want to work on them for our first SQL queries. The SQL query language can be used to do anything within the database. It can select data, insert new data, update existing data, and delete it. It can also be used to create, alter, and delete tables and columns. The first SQL statement we'll learn is a select statement, which provides the basic method of extracting information from your database. The general syntax of a select statement is select columns from tables with conditions. For example, we can select the POP 2008 column from the people table. We can also select all the columns from the people table with an asterisk. Let's execute this last query. We'll begin by importing create engine and creating an engine. Next, we'll establish a connection by using the connect method on the engine. Then we can define our select statement and pass it to the execute method of the connection. This gives us an object that we can use to fetch the results, which we'll be assigning to the variable results proxy. Then we can tell results proxy to fetch all of the results via the fetch all method. Now results will contain all of the data from our people table. Let's pause for just a moment and look at the object that the execute method gave us. That object is called a result proxy, and it can be used in a variety of different ways to get the data returned by our query. When we use a fetch method, such as fetch all on a result proxy, we get a result set that contains the actual data we asked for in the query. This separation between the result proxy and the result set allows us to fetch as much or as little data as we desire. And we'll explore this more in a later section. Let's learn how to work with a result set. In this example, we're using the results from the prior query. We'll start by getting the first row of the results by using an index of 0. By printing the first row, we can see the data it contains. If we want to know what columns are in the row, we can find out by using the keys method. Finally, we print the value of the state column from the first row by using the column name as an attribute on the row object. In the prior query example, we wrote a normal SQL statement as a string. However, manipulating a string to build more complex statements can be very overwhelming. The beauty of SQL Alchemy is that it allows us to assemble these complex statements in a Pythonic way. Pythonic refers to code that adheres to the idioms of Python's common guidelines and expresses its intent in a highly readable manner. SQL Alchemy also hides the difference between database types so that we can focus on the data we want to work with instead of the differences we might encounter in each database type. Let's rebuild the same query using SQL Alchemy. The first 3 steps of creating an engine and establishing a connection will be the same. After that, we need to initialize our metadata and reflect the table as we did in the previous section. Then in line 7, we build our select statement. Now hang tight, we'll talk more about this in a second. Finally, we execute the statement and fetch all the results. The SQL Alchemy select statement works the same as a SQL select statement, and in its most basic form takes a list of column or table objects. For example, statement equals select list of census will select all of the columns of all of the rows in the census table. SQL Alchemy generates the same SQL statement we wrote by hand. We can see that by using the print function on the statement, which outputs select star from census. Now it's your turn to write several SQL queries, both as raw SQL and in the more Pythonic way using SQL Alchemy. We'll be continuing to use the US Census database. Let's practice. Let's execute this last query. We'll begin by importing create engine and creating an engine. Next, we'll establish a connection by using the connect method on the engine. Then we can define our select statement and pass it to the execute method of the connection. This gives us an object that we can use to fetch the results, which we'll be assigning to the variable results proxy. Then we can tell results proxy to fetch all of the results via the fetch all method. Now results will contain all of the data from our people table. Let's pause for just a moment and look at the object that the execute method gave us. That object is called a result proxy. The execute method gave us. That object is called our query. When we use a fetch method, such as fetch all on a result proxy, we get a result set that contains the actual data we asked for in the query. This separation between the result proxy and the result set allows us to fetch as much or as little data as we desire, and we'll explore this more in a later section. Let's learn how to work with a result set. In this example, we're using the results from the prior query. We'll start by getting the first row of the results by using an index of 0. By printing the first row, we can see the data it contains. If we want to know what columns are in the row, we can find out by using the keys method. Finally, we print the value of the state column from the first row by using the column name as an attribute on the row object. In the prior query example, we wrote a value of the state column from the first row by using the column name as an attribute on the row object. In the prior query example, we wrote a normal SQL statement as a string. However, manipulating a string to build more complex statements can be very overwhelming. The beauty of SQL Alchemy is that it allows us to assemble these complex statements in a Pythonic way. Pythonic refers to code that adheres to the idioms of Python's common guidelines and expresses its intent in a highly readable manner. SQL Alchemy also hides the difference between database types so that we can focus on the data we want to work with instead of the differences we might encounter in each database type. Let's rebuild the same query using SQL Alchemy. The first 3 steps of creating an engine and establishing a connection will be the same. After that, we need to initialize our metadata and reflect the table as we did in the previous section. Then in line 7, we build our select statement. Now hang tight, we'll talk more about this in a second. Finally, we execute the statement and fetch all the results. The SQL Alchemy select statement, we execute the statement and fetch all the results. The SQL Alchemy select statement works the same as a SQL select statement, and in its most basic form takes a list of column or table objects. For example, statement equals select list of census will select all of the columns of all of the rows in the census table. SQL Alchemy generates the same SQL statement we wrote by hand. We can see that by using the print function on the statement, which outputs select star from census. Now it's your turn to write several SQL queries, both as raw SQL and in the more Pythonic way using SQL Alchemy. Congratulations on making it through the first chapter. You've become acquainted with the basics of the relational model and relational databases and are now able to make basic SQL queries using SQL Alchemy. In the rest of this course,
on making it through the
you'll
first
beef up
chapter.
your SQL query. You've become acquainted with the basics of the relational model and relational databases and are now able to make basic SQL queries using SQL Alchemy. In the rest of this course,
on making it through the
you'll
first
beef up
chapter.
your SQL query. You've become acquainted with the basics of the relational model and relational databases and are now able to make basic SQL queries using SQL Alchemy. In the rest of this course,
on making it through the
you'll
first
beef up
chapter.
your SQL query. You've become acquainted with the basics of the relational model and relational databases and are now able to make basic SQL queries using SQL Alchemy. In the rest of this course,
on making it through the
you'll
first
beef up
chapter.
your SQL query. You've become acquainted with the basics of the relational model and relational databases and are now able to make basic SQL queries using SQL Alchemy.